Okay, just confirm me. Am I audible? Thank you. Good afternoon. Good afternoon. Good afternoon. Sir, good afternoon, sir. Please pin this link for the WhatsApp. Sure, sure, sure. Give me a minute. Okay. Already I joined in the group. Okay, so let me share my screen. Already I joined in the group which they have been shared in the. Okay, so once again, good afternoon to everyone. From the continuation of our previous sessions, our course RTL design and Verilog HDL order description language. In that, the particularly the today's topic is on introduction to digital electronics. Now we slowly from the high level of understanding the what is happening in the industry, those things we went and looked into it. Then right now we are trying to build a muscle, our knowledge muscle on slowly to our VLSI. So the first thing is digital electronics is very much important, and logic gates and number systems, those things you guys want to be thorough with it. Those all are the building blocks. So you please give some importance to this, and you have to know, because using these concepts only we are going to build the circuits. So don't think this is somewhat already I know such kind of things. No, this is uh, much needed stuffs, because all the circuits are made by using the logic gates only. That is a three simple gates only. Okay, so with this, first let us try to understand what is electronics. Okay, so electronics is a branch of engineering. Okay, previously it was in the physics and something. Then once the engineering domain has been evolved, it comes under the engineering domain. Okay, that deals with the control of movement. That you want to, sir, do the recorder sessions are available, that you can ask with the uh, council for skills and competencies where you have been registered. From there they will be, you will be able to get, I think so. Okay, so let me concentrate on these things first. Okay, so it is nothing but to study the flow of electrons, how the electrons are flowing. That is where the electronics. So in that there are two main categories. One is analog electronics and digital electronics. So something which comes to the storage, whatever the thing, if we are not able to store, then we cannot do it in digital electronics. Okay, so that is what. Okay, so there are two categories. They were telling that there are two categories. Okay, analog electronics and then digital electronics. Okay, so what is in the analog electronics? The signal will be continuously, you can, it goes. Here it is a discrete signal. At one particular time you will have value, at one particular time you are have value, one particular time you will be having a value. So that is where the difference between the analog electronics and the, I mean, continuous signal and the discrete signal. Continuously, so you can have infinite number of points over that. That is where the continuous signal. So that is where they were telling infinite values, and it will be having only zeros and ones. Example, audio amplifier. So right now what I am speaking, that audio noise, okay, audio signal, that is an analog signal. And then when the signal moves inside the computer, and from the computer it is pushing, when it moves inside the computer, it becomes digital. Okay, that is what. So it is whatever the electronic circuits which you are going to use, it is something more noise sensitivity. This is of less noise sensitivity. That is what, when you try to see the old monitors, CRT monitors, it works in an analog stuff. Okay, you can see a lot of wavery kind of sticks, but right now the monitors which are working, it is in the digital forms. So you can see whenever the noise comes inside the monitor or something, you can see only a less, it is only less sensitive to the noise. Okay, those are the simple basic ideas which you want to understand. So nowadays the digital system dominate the modern electronics. Why? Because see, particularly we want to learn, our concentration is on the digital electronics, because whatever the signal you are getting, we will convert into digital. Please try to understand. However the signal may be, in nature the signal are analog, but when you try to do some process, if you want to store something, it want to convert into digital electronics. That is very much important. So something involving in the digital electronics, they call it as digital systems, which dominates the modern electronics, because it is having high reliability, easily we can store the data, and better noise immunity, easy programmability, and compatible with processors and microcontroller. Okay, if you need the material which I was showing the PPT, it is in the attachment, you can download it. Okay, already I have been attached. Okay, so you can download from the attachment. Now the applications in the computers, we use digital electronics, in the mobile phones, embedded systems, and IoT devices, and VLSI chips, and communication systems, in everywhere in the world. If you see any electronic device, it is digital. There will be some storage. Okay, so now we will try to understand the digital signals and its binary concepts. Okay, so we right now we were looking into analog things. These are the analog stuffs. We will be converting into zeros and ones. Okay, somehow you think somehow we are able to convert it into it. Okay, that is a different subject. Okay, converting the analog signal into digital signal, that is an separate stuff. Okay, so right now you think that we all are having signals. So right now we are concentrating on the signals which is having zeros and ones. You keep that in your mind. Okay, so that is where the digital system understand only two logic levels. See, even the computer, even your mouse, even your monitor, and whatever the electronic gadgets which you are keeping it, it will understand only 0 and 1. So we need to speak in the language of zeros and ones, then only the digital system will understand. That's it. This is with the zeros and ones, it is ruling the world. You try to understand. Okay, so now how they are making this as 0 and this is 1. See, really speaking, in a real world, you have only analog signal. There is nothing something called digital, but we are making, you please try to understand, maybe in the storage, and we are trying to differentiate. This is like a memory. You can think this is 0 1 0 1. That means you are storing some voltage. 0 means it is representing some voltage. 1 means it is representing some voltage. What is that voltage? Typically in this TTL logic, they will use 0 is represented as logic 0, and 5 volt is represented as an logic 1. So you can consider -5 for 0, and then 5 for logic 1. Okay, so whatever we tell the 0 and 1, it is for us to understand number system, but actual 0 is 0 volt and actual 1 is 5 volt. You think something like that. Okay, so that means it is stored in a form of analog. Okay, that is the idea. Okay, so you please try to get some clarifications in that. So the real world example, whenever we try to switch operate the switch, 0 indicates off, and then on indicates 1. This is the basics of all digital circuits. Something, a switch you have, okay, when the switch is off, it is 0. When the switch is on, it is 1. Okay, so that is the idea. This is the basic digital circuits. So whenever the signal comes, okay, you try to switch on, switch on off. That means you will get 0 1 0 1, okay, something like that. So from that we are able to convert our analog signal into digital. So this is the basic digital circuits. So you try to get an idea of that. Okay, so now, okay, so in the digital electronic uses different number systems. Okay, sir, why? Because when you talk about the evolution, okay, the number systems evolved. So they thought it is from 0 to 9. They told it is from 0 to 9. That is where the decimal number system. That means 0 to 9. There are 10 numbers. Using that number, they have created a number system that is called decimal number system. Now we have 0 to 9. So if we represent this 0 in zeros and ones, this 9 in zeros and ones, okay, so that is where the binary system. So whatever the number you have, if you are try to represent in zeros and ones, that is called binary system. Sir, why we need this? Because the computer can understand only zeros and ones. So we need some system, we need some system. We want to follow some rules. So that is where the binary number system comes. Then octal system number comes. Octal, it is 0 to 7. Okay, it has its own purpose. Next comes the hexadecimal number. This is very much important. You be thorough with this. Okay, hexadecimal number system, it is 0 to F. So we have the decimal number system 0 to 9 only. Hexa means it is going to be 16. Okay, so A 10 means, B means 11, C means 12, D means 13, E means 14, F means 15. So 0 to 15. That means totally you have 16 stuffs. Okay, so that is where the hexadecimal number system. Sir, already we have a binary number system. In that we have an octal number system. Why again they went and used the hexadecimal number system? You please try to understand. This is a basic. Okay, if you understand this, you will be having a mind-blowing stuff. Okay, see, binary means at the base of 2 you will have either 0 or 1. Using this, we expand by using a 3-bit where you can have 8 possible combination, that they call it as an octal. So only we have an 8 combination, but we have number system 0 to 9. So how I can represent 0 to 9 in terms of zeros and ones? This octal only having a 3-bit, but how can I do that? So they came to an stuff, something called a 4-bit. Okay, 4 bits. So if you try to use 4 bits, you will have 16 combinations, but actual our number is only 0 to 9. So if you went and used only 0 to 9, okay, so till 9 you can use something like this 1 0 0 1. Then what about the remaining things? What about the remaining? It is of not used. So they went and created a stuff called hexadecimal system. So the system can store A, B, C, D, E, and F. So it is the maximum utilization. Okay, just an extra knowledge. So you guys will be able to have a better idea why that number system has been used. Okay, so as I mentioned, whatever the things I was mentioning you in the previous stuffs, this is where the things. Okay, so decimal number system, it is of base 10. I told 0 to 9 and how they are using it. Okay, for example, 452 means it is of it is with 0th place, first place and second place, 0th place, first place and second place. We have to do in powers of 2. Okay, this is the basic. Okay, I hope you guys these are a piece of cake for you. Next, the binary system, it is base 2. Okay, so 0th place, first place, second place, third place, 0th place, first place, second place, third place. Since it's a base is 2, you have to use 2, and whatever the thing you have to use that, and you have to get that is its decimal equivalent. Okay, that is what the idea behind this binary number system. Okay, then octal, the base 8, only 0 to 7. You can see the numbers which will come only in 0 to 7. Okay, so same thing, 0, 0th place, first place, 0th place, first place. Since the base is 8, 8 power, 8 powers, then that number plus you will get this. This is the decimal representation. Okay, so that is the idea behind it. If you go for an hexadecimal, here comes the stuffs. See, 0 to 9, we have the stuffs, but from 10, 11, 12, 13, they used AF, A, B, C, D, E, and F. Okay, so suppose you want to make this. Okay, you want to make this. Okay, so same thing, A is nothing but 10. The place is 0. So it is going to be 10 into 16 power 0. Why 16? The base is 16. Okay, 10 into 16 power 0. Okay, then plus this is 2. 2 into 16 power 1. That's it. Okay, so 16 power 0 is 1. 10 into 1 plus 32. The answer is going to be 42. That's it. Okay, so that is the idea behind these numbers. Okay, so the easiest way to represent the hexa number in the binary thing, you use only 4-bit and try to have a value. This is F. Okay, so suppose if it is 000, it is going to be 8. Okay, so likewise hexadecimal number, something you want to represent this in a binary, 2 you will represent as 0010, and then 10 you will be represent as 1010. That is where the binary representation of this 2a. That's it. Okay, it is so easy. So that I will come that I will be showing in the slide also. But for example, if you want to convert decimal to binary, you know that you have to divide that number by 2 and put the remainder and start from here 10001. Okay, this is the least significant bit. Those things you have to go and put it. Okay, these things you will be able to understand. So I am going a little bit fast. So binary to decimal. Okay, so from binary to decimal, you know that this is the binary number. First 0th place, first place, second place, third place, and fourth place. Okay, so then we are using it the base number 2 system. So 200 and everything, you can go and work on this, and then you can use, and this is the its equivalent decimal number. This is what its equivalent decimal number. Okay, so now binary to hexa. This is the thing which you guys want to understand. So whenever someone asks you to convert a binary number into hexa, it is so simple. You group into 4 bits. Already you have 8 bits. You try to group into 4 bits. You try to separate it. So this is 4-bit separately written, and this is 4-bit separately written. Okay. So as already know, by using 4 bits, you can represent from 0 to F. Okay, so it is 1, 1, 1, 1. It is nothing but 15. 15 is F. That is what F written it over here. Okay, and then group this. It is nothing but 10. It is A. That's it. So easy. Whatever the binary thing, you have to group in 4s and write. Okay, here it is group 4s. You write that over there. Next group, you write that. If you have another group, write that. That is the simplest technique where you can go and convert your binary to the hexa stuff. Okay, now x2 binary, these are the something you needed when you try to do the programming and all such kind of things. These are the needed one. Okay, so c is nothing but a is 10, b is 11, c is 12. Okay, so it is 1100. You write it in an 4-bit. 3 you write it in an 4-bit. Likewise, you put that c thing over here. This is the c thing. Okay, this is the c stuff, and then the 3 that is been written it over here. That's all. As in this order. Okay, as in this order you try to represent it, then that becomes your the result. So easily you can convert this into the x2 binary. Okay, so now the important topics. Okay, see sir, why you went the number system, those and all very much important, you guys want to know. Okay, so now you got an idea about the system, number system, and you got an idea that why we went for hexadecimal system. Okay, because we have numbers from 0 to 9, but we cannot represent the number 0 to 9 by using only 3 bits, because you can represent only 8 numbers, but totally there are 10 numbers. So we cannot use 9 and 10, but in our thing we have the stuffs. So how we can go and do the things? So then they introduced the 4-bit. That is what it is in computer system. Everything is something in an hexadecimal. So you please try to understand this. You if you have a doubt or something like that, so please go and have a thorough understanding of the hexadecimal. Okay, hexadecimal numbers, that is very much important. Next concept. So we somehow try to understand. See, our goal, please try to keep the things in your mind. Our goal is learn the VLSI. Okay, sir, what is the link between the number system and the VLSI? There are lot of stuffs. Okay, so believe me. Okay, so in order to understand the logics and the gates implementation and zeros and ones, you have to understand the number system. Next, in order to understand, in order to develop your own circuit, own stuff, okay, you want to understand the logic gates. No other go. You must understand this. You might be thinking, what is this logic gates? Already I know it. Yes, you know, but you have to know why they have been implemented these things, because in this real world everything is logic. Okay, so logic gates are foundational building blocks of digital electronics. Please keep in this mind. If you are strong with logic gates, if you are able to combine many logic gates, and if you are able to, if your mind can able to process this, you are a good in digital electronics blocks. Okay, so acting as a micro switches that performs mathematical and logic functions. These logic gates only you will be able to do the process, all your process, arithmetic, logic units. Okay, arithmetic and logic operations are done by using this logic gates. That is what I was trying to do. So mathematical operation and logic function, that is nothing but arithmetic and logic. Okay, so you can implement. So please try to understand. These all are the important concepts which you guys want to be thorough with that. So they accept one or more binary inputs represented 0, 1. Okay, so you it is a gate. It can have 1 input or 2 input or 3 input, however it want. This is the logic gate. Okay, you can implement. It can be, sir, we learned only a AND gate, OR gate. We know it is having only 2 inputs. No, we have a gates with 4 inputs, 8 inputs, lot of things are there. Okay, so you please try to understand. So they accept one or more binary inputs and output a single binary result based on the 6 Boolean rules. So there is something called a Boolean rules. There is something called a human rules. Okay, there is something called a human rules. Likewise, there is something called a Boolean rules. That is a different topic. I don't want to touch much on those things. Maybe you can go and revisit your digital electronics. Okay, so that you will be getting an idea. Okay, so in modern technology, billions of these gates are etched into a silicon microchip to power everything from calculator to the computer. This is why we are reading, we are going to understand this logic gates. Now you got the importance of that. Okay, so there are three. So if you consider the basic gates, there are only three: AND gate, OR gate, NOT gate. See, if you try to apply this in your day-to-day life, okay, if I get uh, if I get a good work and a good salary, then only I will marry. Okay, that means I need both good salary and then good work, then only I will get married. So marriage is an output due to salary and good industry. There comes and we are already using in our real life. That is what they converted into something like this. See, the problem, the digital electronics, you please think, the digital electronics solves our our real world problem. Our real world problems is with these three logics. That's all. We make decisions with these three. Or, okay, either I get a good salary or a good company, I will go and marry. That's it. That's it. Or either this or that, and not get. No. Okay, something like that. Okay. If it is not raining, then I will go. Something like that, something in a negative. So these are the three things where in a real life we will start making decisions. They used to see how the people analyzed, you think. Okay, they analyzed in the real world, they converted into a digital circuit where it can go and perform all the operations. It is a good stuff. Okay, so the output is one only if all the inputs, that means both the input want to be one, then only the output one. Here any one of the input is one, the output is one. Here, if the input is one, output is zero. If input is zero, output is one. That's it. You have to think like that. Okay. So next, sir, already you thought you told us the basic gates, sir. Then what is this universal logic gate, sir? What is this universal logic gate? You please try to understand. Okay, if I want to build a circuit, and if I go to the shopkeeper, I need 10 OR gates, 20 AND gate, and 40 NOT gate. Okay, these are something coming around 70 gates. Instead of that, sir, you give me only 70 gates. Which gate? Universal gate, where I can use that universal gate, where by using the universal gate, I can convert that into an AND logic, and I can convert that into an OR logic, and I can convert that into an inverter logic. That is where the universal gate comes. So universal gate means, okay, there are two gates, NAND gate and NOR gate. Using NAND or NOR, you can derive AND gate, OR gate, and NOT gate. How good. Okay, so if you have a NAND gate, if you go and purchase only NAND gate, you can make any circuits. You can make any circuits. Okay, first you don't, okay, guys, you these and all administrators problem. Okay, you please try to access from where you have been logged in. You can go and call them, and you can get an idea about the recorded session is available or not. You can get from their link. Okay, the link they have given me is something different, and the link what you are using is different. So you can go and get the access from them. Okay, so you please it is the session is recorded, but you ask from where you got registered, from there you go and ask, they will be provided. Okay, so please, now these all are the universal gates. Okay, so by using an AND gate, you can go and create the stuffs. So what is NAND gate? So simple. NOT gate with AND gate, that is NAND gate. So the output of AND gate is given to the NOT. That output is going to be the NAND gate. So simple. Okay, that is the idea of this NAND gate. And an OR gate is OR gate, no? Okay, it is not of OR. That is where the NOR gate. Okay, opposite of the OR gate, it is opposite of the NAND gate. Okay, and apart from that, there is a special purpose logic gates. They call exclusive OR and exclusive NOR. This is for the comparing. Okay, so if two inputs are different, okay, if two inputs are different, then only one. If both the inputs are same, then it will become zero. So such kind of comparisons are used for XOR and XNOR. XOR complement is XNOR. Okay, so hope you guys please try to go and get an idea about. I don't want to go much into it. Maybe in the future slides you will be getting more that stuffs, but I highly recommend to understand number system and the gates. Okay, this is the building blocks. Okay, so what all things I have given you, everything I put it in the over here. When it is 0, the NOT is becoming 1, and then AND is 0, OR is also 0 because both the inputs are 0, and NAND is opposite of AND, it is 1. Okay, and you got NOR, both the things are same. In the NAND gate you see that. Okay, in the NOR gate it is also opposite of this. Okay, and XOR, both are same 0, here both are same 1, that's it. Okay, so here both are different 1, both are different, it is 0, both are different 1, both are different, it is 0. So that is how you have to understand this. These things I know you guys will be able to easily understand, but this is the thing. See, both are same 0, both are same 1. That is about this gates. Okay, hope you guys will be able to get a more idea about this stuffs. Okay, so now where we will use these logical gates, if you want to develop an arithmetic logic units, you have to use this logic gates. If you want to add something, subtract something, comparing the numbers, these logic gates are used in that. Suppose you are giving two numbers, this is what your digital circuit, it will compare and tell you, and it can go and add and tell you. So for that purpose, these logic gates are used. Memory units. Okay, gates wired into continuous feedback loop for latches. You see that memory means storage. Memory means storage. Okay, so by using logic gates, you can store 0 and 1. That is how the memory comes. Why we need memory? Because see, without the memory, you cannot suppose whatever the class I have taken yesterday, without having a memory, okay, you think, then again you are attending the today's class, it will be a blank. So memory unit is very much important, where using that, where you can take the decisions or you can go and do the stuffs. So somehow we need the space to store, and somehow we need the space to analyze. So that is what important. So the storage is important. Please try to understand. And next comes the industrial controls. So gates acts as a safety mechanism. Okay, something hazardous happen, it will go on the switch off, and something is good, it will give on allow the stuffs. So these all are some examples which is by using the logic gates, they are implementing a big stuffs. Okay, so this is the basic things I would like to give you an idea. Sir, what sir, 40 minutes, the whole PPT gone. No, I have one more thing also. No worries. Okay, no worries. We are going to see the practicals. We are going to see the practicals. Sir, could you please provide how many times I was telling you guys, please try to understand it. Okay, from where you have been logged in, try to get an idea, try to get an things from them, and you do the stuffs. Okay, Now, yesterday we were been looking into the some practicals. Okay, so now let us try to give some hands-on stuffs to you guys. Okay, still it is good. Okay, okay, okay. So now you go and open an EDA playground. Okay, EDA playground. You go and open a EDA playground and you can press that. It will start loading it. Once it loading, you can see the two things. See, I told I will teach Ubuntu and those things, but right now I am giving one more chances also. Maybe in the online itself where you can go and uh, that are help us a lot who have the improper internet. I understood, but that is not in my hand, please. Okay, I know all the things. The purpose they are recording it something you can go and revisit it. I know it, but you try to get an idea how you got the information about this session from them. You try to get an things and do it. Okay, please try to understand. Okay, that is what I was trying to tell. Now this is the EDA playground you opened. Okay, so something they are telling, write your code in the which is test bench and write your design code. Write your design code. So let us write one basic and whatever the thing we learned, we will try to implement. So I am not going to teach the Verilog. That is a different session. Okay, you go and play with the things without the coding. Okay, I am giving you a confident. If you don't know the logic, also no problem. Go and give it to the AI and try to get the Verilog code and try to put and try to play with it. That itself a big stuff. Okay, so for that purpose only, mainly I kept this session for you guys. Okay, so please, since these things you can do it by the uh, locally also, and this is also another way where you can use the online tools where you can go and work on the stuffs. Okay, so if you open it, it will ask you to sign in through the mail, something like that, and you can put the things. Okay, so this is where your design stuff, your AND gate logic. Okay, you go here. So this is my AND gate logic. I'm not going to tell you what this code is doing. That is the separate session. But before that, I need you guys to be familiar with these tools. So you will be without knowing the logic itself, you know how to use the tools, how to look into it, and automatically you will get an hands on it. Okay, so now this is the AND gate module. I went and wrote it in an code. Whatever we learned in an gate, you know, AND gate, when both the inputs are one, when both the inputs are one, output is one. When any one of the input is zero, the output is zero. So this gives us, okay, so something that thing, if we try to implement in an code how it looks, so there comes the Verilog code and such kind of things, and this is the tool. Okay, so now I am trying to put this over here. This design I am trying to put it over here. You don't think about the something I got from the AI tool. AI has generated a code for an AND gate and I went it. Now I have given the AI and asked to generate an test bench. I want to test whether my gate is working properly or not. Whether my gate is working properly or not, I can go and ask the AI to create for the same gate. You give me a test. Okay, so you see there is a input A and B, output is Y, because the gate is having input A and B. Likewise, we are giving input 0 0 combination, 0 1 combination, 1 0 combination, and 1 1 combination. Okay, did I missed something? Yes. copy, control V. Okay. So all combinations using it, we don't want to test it manually. We can write a software for test it. Okay. Now what I am trying to do is, now the code has been written. So already they have given you one thing. You put the design file here. You put the test bench code here. That is what they were trying to tell. Okay. They were using it. Okay. No problem. Yes. I can go and do that. Okay. Now comes, how do I run? Let me go and run. It is telling somewhere, please select a valid tool or simulation using a tool and simulator menu on the left. Okay, somewhere tools or simulator on the left, something it is telling. So I want to go that tools and simulator. Here I want to choose what is the compiler I want to use the code. I always use the Verilog. I am using this Verilog code. Okay, then let me run it. Somehow it is running something. Okay, let me save it. Something it, I am giving up. Okay, whatever the things, let it give. Okay, I am not leaving it. Let me run it again. Okay, somehow it is telling, somehow it went it with that. Okay, so now let me try to save it and again run it. Maybe I opened twice, it might be giving the stuffs. Okay, the same thing, I went and opened the twice. No, here extra I went and used. Here I downloaded. See, after running completed, it started downloading. How? I went and used this option in the tools and simulator, download the file option. So it has been downloaded, and if you move inside it and if you open it, you can see all the VCD files, and it is having its own script files, how to compile. You see iCarriers and all those things it is able to do, and it can do the things. And you can see our design bench. This is our simulator, I mean the test bench code, and this is what our design code, whatever thing we have wrote, and it is the output file. By using the local, you can go and run it. Okay, so this is one way you can download the file. This is how the file is getting downloaded. Now instead of that, I want to show the waveform. I want to make the things to show the waveform. So I went and clicked this EP wave. Something it is showing with all test cases. A, when A is 0, B is 0, Y is 0 for AND gate. And when A is 0, B is 1, it is 0. When A is 1, B is 0, it is 0. You can see that. You can see the stuffs. Okay. When A is 1, B is 1, you can see Y is 1. So I have a tool where I can go and verify what all the circuits I have went and implemented. So these are some things which you can go and use it. Okay. So now the problem comes. So you see, I went and scrolled it. You can see here the right side, the close button. If you close it, you will be getting it. Okay. Since I went and enlarged it for you guys, we can go and do it. Okay. So this is one way where you can go and play whatever the things you are learning in these concepts. You can go and play with these stuffs. Okay. The next thing what I want to introduce to you all is, okay, I already showed you the stuffs. Okay, let me go and download it, and let me try to use that. Maybe let me go and download. Okay, in the result. Okay, let me open the terminal. Okay, let me try to use iVerilog, and what are the files I have. Let me go and compile it. Okay, design.sv, test.sv, hyphen o, sim.out. Okay, vvp sim.out. It created a VCD file. So gtk wave dump.vcd, I'm able to see whatever the things I'm able to see in the uh, okay, it went and used it over here, and for 40 nanoseconds. Okay, the same signal I am able to look it over here. Okay, so here, let it go to over here. You see the signal goes, the signal y equal to 1, maybe for the signal, this signal. Okay, so you can, if you need, in the first session and second session itself, I was giving you all the things to install the uh, uh, install the code and all those stuffs. Okay, and then software, and from the simulation tool you can download the code and you can use that and you can go and test the stuffs. Okay, so I have given you both the ways, so you can go and work whichever way you want. You can go and work and you can get an idea, and you can go and do it. Okay, so this is what I planned for today's sessions. So you please work on the stuffs and uh, try to get more idea about however you try to have an what I am trying to tell is, if you are guys able to work with the practical apart from the theory, yes, you have to understand the theory, but the practical is more important stuffs. So you start playing with the, first I recommend you guys to play it with the EDA playground, then slowly started working with the local downloader stuffs. Okay, so meanwhile you try to understand how to install the ubuntu's and how to install the stuffs, those things we can go and get it. Okay, so please guys, we have an some more minutes, so where you can go and work on the uh, work on the, I mean, you can ask questions. Sorry. If you have any doubt, please ask. Now you ask the questions. Sir, how to watch recorded session? I don't have answer for this, boy. I really don't have answer. I don't have answer. Maybe I can show you. Okay. Maybe I don't have answer. Maybe at the end of the slide, you might be having the answer for it. End of the slide, Chandu, Vasu, the end of the slide maybe it might be help you. Okay, any other doubt? What do you ask is done. Okay. 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 Okay, guys. Thank you. So see you tomorrow. Okay. So meanwhile, you guys try to practice. You try to practice. Okay, I will send, no problem. Okay. Bye. Yes, yes. Okay. Bye. See you guys.